So, good morning, Miss. Good morning, classmates. We are the Group 6, and the assigned topic for us is about climate change. So, before I will formally start with my discussion, let me first introduce myself. My name is Jeneline Abihero, BAC 1E. So, the lesson objectives is at the end of the lessons that students should be able to first identify the costs of climate change. Second is to understand the effects of climate change on the society. And lastly is to illustrate how the community helps in mitigating the hazards caused by climate change. So, the Intergovernmental Panel on Climate Change, IPCC, a United Nations body that evaluates climate change science, released its report on global climate change. So, the reporters' important conclusion were the following. First, the world climate has changed significantly over a past century. Second, the significant change has human influence using climate models, and if the trend continues, the global mean surface temperature will increase between 1 degree Celsius and 3.5 degrees Celsius by 2100. So why should a few degrees of warming can be a cause for a concern? According to the experts, global climate change could have greater potential to change life in our planet than anything else except the nuclear war. So, these changes will also be lead a number of potential serious consequences. The scientific community and government across the world are in one agreement. The climate is changing. So based in what in our observation, so makabantay man siguro mo nga compare to the past century o karon mas init ang atong panahon karon compared to the past century. But first, what is climate change? What causing it and how will it affect us? So, a climate can be described as average weather over a period of time. So, the climate change can be referred to the statistically significant changes in the climate for a continuous period of time. And so, the factor that contribute to climate change can be natural occurrence processes, external forces, and persistent anthropogenic changes in the composition of the atmosphere in the land use. So, a climate change can also be due to natural occurrence or by contributed by the acts of human beings. So, example for the natural occurrence are those katong volcanic eruption. So, since mubuto tong volcan, ang katong ashes niya is mapunta man to siya sa atong atmosphere. And also, the example for the acts of human beings is the prone example niya is kanang mga kuan sa manufacturing or kanang pag-burning of fossil fuels, burning oils, mga ingana. So, climate change means a significant change in measure of climates, such as temperature, rainfall, or wind, lasting for the exceeding period, or it can be decades or longer. So, climate change is a global phenomenon of climate transformation characterized by the changes in the usual climate of the planet that are especially caused by human activities. So, in these lessons, we will present the causes of climate change and its effects on the society.
analysis the causes of climate change. The causes of climate change could be natural or by human activities. First, natural causes is volcanic eruption. Volcanic eruption are one of the natural causes of climate change. When volcanic erupts, it emits different natural aerosol like carbon dioxide, sulfur dioxide, salt crystal, volcanic ashes or dust, and even microorganisms like bacteria and viruses. The volcanic eruption can cause a cooling effect to the lithosphere because it emitted aerosol. It can block a certain percentage of solar radiation. These cooling effects can last for 1 to 2 years. What happened in the violent volcanic eruption is the release of ash particle in the stratosphere. The volcanic ashes, which have sulfur dioxide combined with water vapor, it then formed to sulfuric acid and sulfurous aerosols. The sulfurous aerosols then are transported by easterly or westerly winds. Volcanoes located near the equator are more likely to cause global cooling, which of the wind pattern. Volcanoes located near to the north or south poles are likely to cause cooling because of the pole winds the patterns. The sulfurous aerosols are confined in the pole areas. Several recorded major volcanic eruptions that caused climate change. First is the Mount Tambora of Indonesia, erupted in 1816. It was considered as the largest known eruption in the human history. The eruption caused snowfalls in the northeastern United States and Canada. It affected their agricultural lands, losing crops that caused food shortage and increased human mortality. The eruption of Mount Krakatau of Indonesia in 1883 and Mount Pinatubo of the Philippines in 1991 contributed to the cold years of the planet Earth.
Good morning, ma'am. Good morning, classmates. So, today's discussion, we were going to talk about orbital changes. So, here's the introduction. What is orbital changes? Orbital changes, the Earth has natural warming and cooling orbits caused by Milankovitch cycles or variations in the tilt and orbit of the Earth around the Sun. So, Earth orbit can also cause climate change. This was proposed by Milankovitch theory. The Milankovitch theory states that as the Earth travels through space around the Sun, cyclical variations in three elements. So the three elements we'll discuss later. So sun geometry combined to produce variations in the amount of solar energy that reaches academic Emporia 2017. So this is some examples of Milankovitch cycle. So that's all. Thank you.
So good day everyone, my name is Arjelian Aningaro and this day I'm going to discuss the Milankovitch cycle. So first of all, who discovered the Milankovitch cycle? So the person discovered Milankovitch cycle is Milutin Milankovitch. So who is Milutin Milankovitch? So Milutin Milankovitch was born on May 28, 1979 in Croatia and died on December 12, 1958 in Serbia. So he is a Serbian mathematician and a geophysicist best known for his work that linked long-term changes in climate astronomical factors affecting the amount of solar energy received at the Earth's surface. He is also responsible for the creation of the Milankovitch cycle, or which is known as the Milankovitch theory. So this cycle or theory explains that the difference in climates and temperatures around the world or all over based on the changes in Earth's orbit or axial rotational or the axial tilt. So for this discussion is I provide some pictures to further understand the Milankovitch cycle and its elements. So the elements of the Milankovitch cycle has three. So these are the eccentricity, the obliquity, and the precession. And later I will discuss those three. But before that, let's answer this
The
question.
Milankovitch cycles occur. So Milankovitch calculated that the Ice Age occurred approximately 41,000 years. Subsequent research confirms that they did occur at 41,000 year interval between 1 and 3 million years ago.
And also, Milankovitch cycle also include the shape of the Earth's orbit, or known as the eccentricity. The next is the angle of the Earth's axis is tilted with respect to Earth's orbital plane, known as the obliquity, and the last is the direction of the Earth's axis of rotation is pointed, known as precession.
As what I have said earlier, the Milankovitch cycle has three elements. So these three elements are the first is eccentricity, second is the obliquity, and last is the precession. So first is we need to tackle about eccentricity. So what is eccentricity? So eccentricity describes the degree of variation of the Earth's orbit around the Sun from circular to more elliptical. So eccentricity also has two main periodicity. The first one is the one cycle with an average of 100,000 years, and the second one with a longer cycle with a periodicity of 413,000 years. So next is the obliquity. So what is obliquity? So obliquity describes the tilt of the Earth's axis in relation to its orbital plane, which ranges from 21.1 to 24.5 degrees with a periodicity of 41,000 years. So next is the precession. So what is precession? So precession describes the motion of the Earth's axis of rotation, which does not point toward a fixed direction in the sky through time. Instead, the axis of rotation describes a clockwise circle in space, like the spinning of a wobbling top with a periodicity of 19,000 to 23,000 years. So, according to research, over a century ago, Serbian scientist Milatan Milankovitch hypothesized that the long-term collective effects of changes in the Earth's position relative to the Sun are strong driver of the Earth's climate long-term. And it is also responsible for triggering the beginning and the end of the glaciation period or the Ice Age. So in year 1976, a study in journal Science by Hayes and et al. Using deep-sea sediment core found that Milankovitch cycles correspond with period of major climate changes over the past 450,000 years, with Ice Age occurring with Earth was undergoing different stages of orbital variation. Thank you.
So, good morning everyone. Before I formally start with my discussion, let me first introduce myself. My name is Jenilyn Abihero, BSc 1E. So, the assigned topic for me is the carbon dioxide theory. So, why does carbon dioxide theory matter in climate change? So, unsa man day naa sa carbon dioxide nga usa man siya sa causes of climate change. But before I will discuss in that matter, I will formally define what a carbon dioxide is, since we already know that a carbon dioxide is made up of one carbon atom and two oxygen atoms, and also a colorless and non-flammable gas at normal temperature and pressure, although much less abundant than nitrogen and oxygen in our Earth's atmosphere. The carbon dioxide is an important constituent of our of our planet's air. And also, a carbon dioxide is a transparent to sunshine but not invisible to infrared radiation leaving the ground. So, the carbon dioxide also absorb part of the infrared radiation in the air and returns it into the ground, keeping the air near the surface warmer than it would be if the carbon dioxide did not act like a blanket. Next is, why does carbon dioxide matter? So, since we already know that carbon dioxide is one of the greenhouse gases, a carbon dioxide is a gas that absorbs and radiates heat warmed by the sunlight, Earth's land, and the ocean surfaces continuously radiates thermal infrared energy. So unlike the oxygen or the nitrogen, which made up the most of our atmosphere, the greenhouse gases absorbs that heat and released it gradually over time. So like the bricks in the fireplace after the fire goes out. So without that, without this natural greenhouse gases, the Earth's average annual temperature would be below freezing instead of close to 60 degrees Fahrenheit. But an increase in greenhouse gases have tipped the Earth's energy budget out of balance, that trapping additional heat and raising Earth's average temperature. So, meaning the carbon dioxide strong influence to climate is its ability to absorb heat emitted from the Earth's surface and to keeping it escaping out to space. And so lastly, the carbon dioxide theory. So the carbon dioxide theory states that as the amount of carbon dioxide increases, the atmosphere becomes opaque over a large frequency interval. So the outgoing radiation is trapped more effectively near the Earth's surface and the temperature rises.
The other causes of climate change is human activities. Humans are increasingly influencing the climate and the Earth's temperature by burning fossil fuels, cutting down forests, and farming livestock. This adds enormous amount of greenhouse gases to those naturally occurring in the atmosphere. That results in increase in the greenhouse effect and global warming. Human activities contributes to climate change, and the largest known contribution comes from burning fossil fuels. For a reason that when fossil fuels are burned, it releases a large amount of carbon dioxide, and the carbon emissions trap heat in the atmosphere that leads to climate change that is obviously occurring in today's world. Greenhouse gases and aerosols can affect climate change by altering incoming solar radiation and outgoing infrared radiation that are part of Earth's energy balance. Since the start of industrial era about 1750s, the overall effect of human activities on climate has been a warming influence. So this record shows that the climate system varies naturally over a wide range of time scale. In general, climate change prior to the Industrial Revolution in 70s, it can be explained by natural causes such as solar energy, volcanic eruption, and natural changes of greenhouse gases. But in recent climate, however, cannot be explained by natural causes alone. It's because humans or the humans' activities are the dominant causes of global warming. As what you've noticed, the earth are getting hotter. I do believe that in every actions that we take, there is a corresponding consequence. And the example for that is the human activities. For human activities gives rise to the issue of a climate change. That is indeed a serious issue in today's world that needs to be addressed immediately. For human activities results in emissions of four principal greenhouse gases, namely the carbon dioxide, methane, nitrous oxide, and the halocarbons, or a group of gases containing fluorine, chlorine, and bromine.
Another human activity that contribute to climate change is ozone. So ozone is another greenhouse gas that is continually produced and destroyed in the atmosphere by chemical reactions. Ozone is a triatomic, very reactive form of oxygen that is a bluish, irritating gas of pungent odor that is a major air pollutant in the lower atmosphere but a beneficial component of the upper atmosphere, and that is used for oxidizing, bleaching, disinfecting, and deodorizing. Depending on where ozone resides, it can protect or harm life on Earth. Most ozone resides in the stratosphere, a layer of the atmosphere between 10 and 40 kilometers above us, where it acts as a shield to protect Earth's surface from the sun's harmful ultraviolet radiation. With a weakening of this shield, we would be more susceptible to skin cancer, cataracts, and impaired immune systems. Closer to Earth, in the stratosphere, the atmospheric layer of the surface up to about 10 kilometers. Ozone is a harmful pollutant that causes damage to lung tissue and plants, but ozone is extremely valuable since it absorbs a range of ultraviolet energy when an ozone molecule absorbs even low-energy ultraviolet radiation. It splits into an ordinary oxygen molecule and a free oxygen atom. Usually, this free oxygen atom quickly rejoins with an oxygen molecule to form another ozone molecule. Because of this ozone-oxygen cycle, harmful ultraviolet radiation is continually converted into heat. So the last one is halocarbons. Halocarbons are mostly man-made chemicals used in a range of applications over the past century. Halocarbons comprise a wide range of gases. They are compounds that only contain carbon and one or more halogens such as fluorine, chlorine, and bromine. Halocarbons released by human activities destroy ozone in the stratosphere and have caused the ozone hole over Antarctica. Humans produce halocarbons. By a large amount of the naturally occurring halocarbons are created by a wood fire, dioxin for example, or volcanic activities. These three representatives, thyroxine from humans, thyrian, purple from snails, and fluoroacetate from plants, also show that unrelated species uses halocarbons for several purposes. On September 16, 1986, an international treaty was adopted and it is called the Montreal Protocol. The Montreal Protocol on substances that deplete the ozone layer, also known simply as the Montreal Protocol, is an international treaty designed to protect the ozone layer by phasing out the production of numerous substances that are responsible for ozone depletion. In 1987, the Montreal Protocol finalized a global agreement to protect stratospheric ozone layer by phasing out the production and consumption of ozone-depleting substances, or the ODS. By increasing the abundance of greenhouse gases in the atmosphere, human activities are amplifying Earth's natural greenhouse effect. And that's all. Thank you.
Global climate change has already had observable effects on the environment. Effects that scientists had predicted in the past are now occurring, such as loss of sea ice, accelerated sea level, and more intense heat waves. Climate change affects basic elements of people's lives, such as water, food, health, use of land, and the environment. With the average global temperature, and is predicted to rise within the next 50 years, glaciers will continue to melt faster. When we say glacier, it is a persistent body of dense ice that is constantly moving under its own weight. A glacier forms where the accumulation of snow exceeds the ablation over many years, often centuries. Melting of glaciers will increase flood risks during wet season. Drought are likely to decline hundreds of crop yields that will result to insufficient purchase and production of food. According to Stern 2007, ocean acidification will have a major effects on marine ecosystems. When we say ocean acidification or ocean acidification, it refers to a reduction of pH of the ocean caused primarily by an uptake of carbon dioxide from the atmosphere.
These are also the effects of climate change. Climate change will increase worldwide deaths of malnutrition and heat, and vector-borne diseases such as malaria and dengue fever could become more widespread if effective control measures are not in place. Rising sea levels may result in flooded areas each year with a warming of 3 or 4 degrees Celsius. There will be a serious risk and increasing pressures for coastal protections. Ecosystems will be particularly vulnerable to climate change, with one study estimating that around 15 to 40% of species face extinction with 2 degrees Celsius. The consequence of climate change will become disproportionately more damaging with increase of warming. Higher temperature will increase the chance of triggering abrupt and large-scale changes that lead to regional disruption, migration, and conflict. Warming will also induce sudden shifts of regional weather patterns like monsoon and El Niño. Such changes may have severe consequences for water availability and flooding in tropical regions and threaten the livelihood of billions. Lastly, melting or collapse of ice sheets will raise to sea levels and eventually threaten at least 4 million kilometers square of land, which today is home of 5% of the world's population.